Hey everybody, and welcome to the next video for the project Build a Data Analysis Library from Scratch in Python. In this video we are going to begin coding, so this is where the real fun begins. And this is step 1 out of 40, and in this step we will check the DataFrame constructor input types. So let's go over here and hop on over to VS Code where we have our dundery.init.py file open. Again, this is the only file that will be edited throughout the entire project. And the way the project has been created is that the methods that you are going to complete basically just come in order on the way down. So you won't have to kind of hop around the entire file. You should just go vertically down and complete the methods as you come across them in order. Okay, so let's go ahead and look at step 1, check DataFrame constructor input types. So this DataFrame, whenever our users are going to construct an instance of this DataFrame, they have to pass it a single parameter named data. This parameter, we're going to enforce that it is a dictionary of strings mapped to one-dimensional numpy arrays. And this is what this first step is going to do. It's going to check that data is in fact a dictionary that maps strings to one-dimensional arrays. So those strings will eventually be the column names of our data frame, and the numpy arrays will be the values for those columns. So yes, so this dundery init method is what gets called when this is a special method, and this is what Python uses to initialize initialize the object upon creation. So this method is actually already complete. So it has several other method calls that it makes. You will not have to edit the dundery init method. Instead, we will have to edit some of the methods that it calls. And in this video, in this step, we're going to edit the check input types method. So we're down here. We're only going to be editing the check input types method. Now the first thing before we get started is that you'll notice there's a single underscore preceding check input types. This is denoting that this is a private method. This is not meant to be accessed by the users. It is only meant to be accessed internally within this class, like in this file. Now, in Python, there is no such thing as private methods, technically, meaning that our users can call this method if they so choose. But we use convention in Python instead of another keyword to denote that this is strictly meant to be used internally and is not a public method for our users. So, IDEs like Jupyter Notebook, whenever you're coding, will not by default even show these private methods because they introspect the code and they see that, well, if it begins with a single underscore, it is not meant for public use. Okay, so this is exactly what check input types is going to do. Number 1, it's going to raise a type error if data is not a dictionary. Number 2, it's going to raise a type error if the keys of data are not a string. So if the keys must be strings. And then again, another type error if the values are not numpy arrays. And lastly, we're going to enforce that our users only give us one-dimensional numpy arrays. So that's what this method needs to do. And once we complete these things and ensure that our data, that the data parameter follows these 4 bullet points, then we can see if we pass the test. Okay, so let's go ahead and delete pass and see if we can go ahead and complete the first part of this. So raise type error if data is not a dictionary. So if not is instance, so is instance is a function that is able to check whether an object is of a particular type. So the way it works is that actually VS Code is nice and will pop up this help menu, the documentation. You give it an object first, in this case it's going to be data, and then we're going to check what class it is. Or you can give it a tuple of classes as well. So if you want to say, is it an instance of 2 or more classes? Or there's possibilities of it being not just one class. Okay, so we're going to check if data is a dictionary. So dict is the class name. If it is not a dictionary, we're going to raise a type error. And so the raise keyword is how you raise an error. And if we don't have a dictionary, we're just going to give the user a message. We'll say that data must be a dictionary. Okay, so that completes that one part of it. Now, we can actually go ahead and test this out in the notebook. So I told you that it's good to manually test things out. So you can just see if it's working or not before you run the formal test. So let's go ahead and do that. Now I'm going to split this terminal real quick. I know my face is somewhere on the right-hand side, but so let me go ahead and move this up real quick. I'm going to, first of all, I have to activate this over here. I will go ahead and launch the Jupyter Notebook on this side of the terminal since this is the one covered up by my face talking. And I won't need to use that portion, so that's okay. Let me go ahead and put this back down. So this is just running the Jupyter Notebook, and I'll issue the other commands over here. And you know what? We can actually minimize the left-hand side and give us quite a bit more room on our screen. We don't need to look at the File Explorer, during our coding for this session. So let's go ahead and go back to Jupyter, and we'll open up a notebook. And let's go ahead and so none of the code has been executed. It's important to run auto reload. So let's go ahead and run that. And then this is just some default data frame that we can use for testing. But what we want to test in this case is what we just coded. So we said if the input is not a dictionary, it needs to raise this type error. So let's go ahead and do that right now. Let's see if we can raise a type error. Let me give myself a little bit more room. So if I pass this, say, 10. 10 is not a dictionary. So I should get that type error that I just created. So it says data must be a dictionary. Okay, great. Fantastic. Now, so that is how I check my code in the Jupyter Notebook. So let's me iterate pretty quickly. Now, if I do give it a dictionary, so I'll just say D is, I don't know, some dictionary. We'll just say this. So it's just a single item dictionary. And I try it again, Pandas Cub. Then I will not get any error at all. This is just the current representation of it, which is not very useful at the moment. Okay, so that's fine. Now let's go and finish the other parts. We can just do all of them, or one at a time. All right, so let's keep going. So if the keys of the dictionary, so if the code reaches this line, then we're guaranteed that data is a dictionary. So we could say if not the data, if the keys, so we need to check if all of the keys are not strings. So we're going to have to go through one by one of the keys and check and see if they are not strings. So because there could be multiple keys in the dictionary. So we're going to say for key in data, So we're going to go ahead and iterate through here. And you know what? We are going to the way you iterate through a dictionary the way you iterate through a dictionary to return the key and the value is with the items method. So data is now guaranteed to be a dictionary. So this will iterate through every combination of key value pairs that are in the dictionary. So if we say not is instance, if the key is not a string, then we're going to raise a type error. And we'll say that, we can say the keys of data must be strings. Okay, so let's go ahead and run this again. So let's make this key something else. So if we run this, we're not going to get an error. But if we say our dictionary is some integer as the key, so 10 would be the key here, then it's going to raise a type error. So the auto reload automatically reloads the new code. So it just says so I just triggered that error. So it looks like everything is good. The keys of data must be strings. So I need to have some string here. Okay, good. So that passes that. It's a dictionary with all the keys as strings. In this case, we just have one key value pair. Okay, great. So that takes care of this one. Now it says raise a type error if the values of data are not numpy arrays. Okay, so if it passes the string, we still need to check and see if the value is a numpy array. So we're going to say if not is instance value, and we want this to check whether it's a numpy array. Now, I have already imported, the numpy library is already imported as the first line in the file up here. So if you're not familiar with numpy, you might not know what the underlying class is, but it is a ND array. That is the name of the class. So if this is not a numpy array, we're going to raise a type error, and we'll say values of, I use the backtick to signify a, this is like some of the code. Values of data must be numpy arrays. Okay, good. So I think that takes care of that one. Let's go back to our notebook. So here we have our dictionary, and maybe we'll just call it data so it maps exactly with what we have. Now our value here is a integer. So this should create the error that we just did. It says values of data must be numpy arrays. Okay, great. So let's make sure it is a numpy array. So we'll just say ARR is, I've already imported numpy up there, and we'll just say it's an array, and you know what, we will make it a two-dimensional array. Okay, so just so you can see what this array looks like, this is a two-dimensional array. Let's make it 3 rows and 2 columns. Okay, so now we know for sure it is two-dimensional here. Okay, so yes, so now if we run this, it should pass the test, and I did not actually put it right there, so data did not get written properly. So data is going to be an array that has a key, that's a string, and a value that is a numpy array, and now this will be valid for my constructor at this point in time. Okay, the last step to this is raise a value error if the values of data are not one-dimensional. Okay, so we need to check that this value is a one-dimensional array. So in this particular example over here, our array is two-dimensional, so this is not going to fly. We need to check the number of dimensions. So now we're not checking an instance. It's no longer going to be a type error. It's going to be a value error. You can raise whatever errors you want, by the way. There's a number of different errors that are available right out of the box that Python gives you. But type error and value error are two of the most common errors that you will raise, and these are basically just about the only errors we will raise. So we either have some wrong type or there's some sort of wrong value. In this case, it's the wrong value. We have the wrong number of. We want to check and see if the dimensions are correct. All right, so now we're guaranteed that value is a numpy array. So if value, and you would not know this unless you know numpy, the ndim attribute returns the number of dimensions. So we're going to say if number of dimensions is not 1, so we're going to be forcing it to be 1. We are going to raise a value error, and we're going to say values of data must be a one-dimensional array. Okay, so let's go back here and to our Jupyter Notebook, and let's rerun this and see if we get that value, if we've triggered that value error. So there we go. It says values of data must be a one-dimensional array. All right, fantastic. So we've done all 4 cases right here. And it looks like check DataFrame constructor input types is all ready to go. Now, we've manually verified it. This is what I mean by manually testing. So everything looks good. So if we look back in the Jupyter Notebook, we can let's just create a new array, say array 1, and we'll make this one-dimensional. Let's put in some random numbers. So instead of data having this two-dimensional array, we'll just say it's one-dimensional, and just so you can see it right here, it is a single-dimensional array. And now data, we should be able to not give us any error, and it does not. All right, now just because we've passed the manual test does not mean we have passed the automated test in PyTest. This is what we need to do. We are going to run a single test. It's contained in the test-dataframe.py file, in the test-dataframe creation class, and in the test input types method. So let's go ahead and look at that test. So I'm going to go ahead and open up the test folder. I'm going to open up test dataframe. Under test dataframe creation is test input types. So this is the test that it needs to pass. This one right here. So this is what PyTest is going to run. It's going to run this method and see if it passes this test right here. So let's go ahead. You can just copy and paste this command into your terminal. So here it is. And if you've passed the test, it'll say we've only run one test. So it says it collected one item, and there'll be a single green dot, and then it'll say one passed. If you failed the test, it will say one failed. So this passed, and we're happy with this. We'll close out of that. So it looks like check input types has passed our test, and that's what we're required to do to continue on to the next step. So I'm just going to stop there. Let me just recount what we did. So we fired up a Jupyter Notebook so that we could manually test the auto reload, which is the first thing that was one of the first things that was run. Helped us tremendously because we were able to make changes to our code and then go back to the Jupyter Notebook and see the changes happen like in real time without having to restart the kernel. So that's a valuable tool. And we went ahead and raised 4 errors for 4 different situations. The end result is that we have a numpy array with, data is going to be a dictionary of strings mapped to one-dimensional numpy arrays. All right, so that's it for check input types in step 1. Hope you enjoyed coverage of step 1 and are looking forward to the other 39 steps. So we're going to check the array lengths next.